Ladies and gentlemen, welcome back to another episode of The Encounter, where we talk to senior leaders from the tech industry to get their unique perspectives and insights. Today, we have a very special guest joining us. I have the pleasure of inviting Arun Gupta, a well known open source and cloud native technology leader. Arun, it's great to have you on the show.
Jankiram, I'm super excited to be here.
So, before we get started, let me introduce Arun. I first met Arun in Chennai in 2000. Yes, that's 23 years ago when I first met Arun. He traveled to Chennai to speak at one of the Sun Microsystems event as a Sun developer evangelist presenting on EJB and J2EE. And since then, we have been in touch. I have seen Arun move roles, switch companies, but his passion for technology is very inspiring and infectious. So he worked at Red Hat, at Couchbase, at AWS, and Apple, leading their platform and developer advocacy efforts. Arun is the chairperson for CNCF governing body, and is also a governing body board member for Open Source Security Foundation. He's currently the VP and GM for Open Ecosystem at Intel Corporation. Let's get started with Arun's interview. I have seen you at multiple companies and your current role is at Intel. So why don't we start with the background and what you do at Intel?
Absolutely. I joined Intel over a year ago. I am the VP and the general manager for Open Ecosystem team here at Intel. And my role here is to define and implement the strategy for open ecosystem all across the company. Now, usually when we talk about open ecosystem, it's a much bigger term. Open source is a key component of it. But what we also include is open API, open spec, open hardware, open data, you name it. Anywhere and everywhere there is open happening at Intel, my team gets involved and we influence and we define the strategy to make it a more holistic strategy. So it's very exciting time here. Greg Lavender, when he reached out to me last year, he says, Arun, we would like you to build that team. And it's like, what do you do at Open? Like, I have no idea about Intel and Open. And he said, that's exactly the problem we want you to fix. So I'm really here. I say my main role here is to be the chief storytelling officer about all the excellent work that Intel does in open ecosystem and why we do it, more importantly.
Great. So what exactly is open ecosystem?
Yeah, as I said, open ecosystem really means, open API, open source, open hardware, open spec. So think about, Intel contributes to 300 plus community managed projects. And these are pick the project that you care about: PyTorch, um, TensorFlow, OpenJDK, Kubernetes, any project that comes to your mind, Cassandra, Kafka, pick a project. Because usually our customers, who use our silicon, whether it's in a private data center or a public data center, on a smart edge or a client, they consume our projects, they consume our product, which is silicon, essentially using these open source projects. So we make sure that we are contributing to these projects, things like, all the projects that I mentioned and much more. We want to make sure that these projects are fully optimized for our hardware. They are able to leverage the latest instruction set, and they're able to leverage the latest accelerators, so that off the shelf, when customers download these projects, they have the ability to run them in the most optimized manner. So that's sort of the broader open ecosystem specs here. And then in addition, for example, my team also works with the Intel Foundry services, as they're embarking on the RISC-V journey. Then we also work with the One API team, which is an API that we have created that allows you to do open accelerated computing, where you're not logged into a walled garden, but you could really traverse across multiple horizontal architectures. So my point is that open ecosystem is really an encompassing term where open source is a big element of it, but then it's a lot more encompassing as well.
Perfect. So Arun, we know you as a cloud native person and you have contributed to the strategy at AWS and you have been a part of the cloud native ecosystem as an influencer. So Intel is not known to be a strong player in the cloud native ecosystem. So how do you bring these two together?
Well, actually, I would challenge that. I think Intel is a very strong player in cloud native ecosystem. The moment you say cloud, pick a cloud, private, public, whatever, right? AWS, Microsoft, Google. You pick a cloud. In all of those clouds, the good thing is that there are other vendors that are also, increasing their share. But Intel is by far the most prominent architecture that is running in these clouds. So if you are running an application in the cloud, Intel is very much part of it. And that's what I meant by saying. So the fact that you are building your Java application and you want to run it in a most optimized manner in a Kubernetes container, we are touching that entire layer for you because we are optimizing Java to leverage our latest silicon features so that it is giving you the most performance centric application. It is running in the most optimal manner. The memory consumption is low because end of the day, if you think about it, when you're building a cloud native application, you're running hundreds and thousands of microservices all around the place. The fact that each microservice could be started up on any particular VM, for example, what that means is that the Docker image or the container needs to be downloaded on demand. Now, if that container is big, if it is going to run in a longer time, that's going to be that much more cost to you. And that's where we think about, because we have optimized Java, because we are running Kubernetes, we are optimizing Kubernetes to run in a scalable manner on your CSP. Because of all the work that we are doing up there, it is very, very relevant in that cloud native space. And that's where, my role here at Intel is I work very, and there are hundreds of people at Intel that contribute to the cloud native projects essentially. As a matter of fact, Kathy Zhang, she is the second time elected member to the Technical Oversight Committee of the CNCF. Patrick Oley last year won a Chop Wood Carry Water award at KubeCon Detroit. So there are people, and there is Marlo Weston. She started the sustainability tag at CNCF. So there are several folks from Intel in a leadership position, and cloud native is very fundamental to what we do and how we do.
Awesome. Thanks for clarifying that. Personally, I have used the One API and Intel Modin, which has the optimized flavors of TensorFlow, PyTorch, scikit-learn, and I've seen significant, performance improvements when we target Intel Xeon and even desktop grade processors. So when you package them as Docker containers and run them in microservices for inference, I think it all starts to make sense.
Exactly.
So
But
yeah,
and I
so
think that's what
thanks.
you got to think about. Our philosophy is, yes, we are primarily a silicon company, but silicon all the way to the app. Whether it's the actual hardware, whether it's the firmware, whether it's the operating system on top of that. Intel has been the top contributor to Linux kernel for over 15 years. We are among the top 10 contributor to Kubernetes. We are among the top contributor to JDK. We are among the top 5 contributor to PyTorch. So if you think in that terms, all across the stack, we have been contributing extensively just to make sure that developers get the most seamless, streamlined experience for these popular open source projects.
Right, right. So, Arun, I know you as a very hands-on person, all the way from Sun to Red Hat to Couchbase, Apple, AWS, and we interacted quite a bit when you were at AWS. So, you have seen the evolution from good old J2EE to the most recent Kubernetes, and very few actually, been through this entire journey and staying very hands-on. So, what do you think is the next big wave? Having seen all these transformations and survived all these waves, like me, it makes us feel old. But the fact is, yes, we have seen the evolution of J2E, EJB to Kubernetes pod.
Yeah, EJB still gives me PTSD. So I know what you mean. But I think, the important element to think about this is, if you go back in the history of computing, earlier the innovations, like a major innovation would happen like every several years. But now that innovation cycle is shortening, right? So over the last 20 25 years I've been here, I've seen how J2E has come about. Then Spring came about, then J2E and Spring were competing with each other. Then Go came about, then Rust came about, then Kubernetes came about, Docker came in between. So I think every 3 to 4 years there is something new that comes up, and that kind of shakes up, on how you truly think about the application. Honestly, the kind of excitement I felt, gosh, I was playing with Docker back in 2013-ish timeframe, 2013, 2014 timeframe, and I was super excited on what the ability Docker brought to the application, where you literally build your application once and run anywhere, and it transcended very well from Java, because Java was write once, run anywhere. Docker was package once, deploy anywhere. And Kubernetes take it to the next realm, where it actually truly democratized the compute platforms, which is pretty cool. I think that kind of excitement now I see with the capability that AI is bringing into everything. And if you think about generative AI, and not just generative AI, but general AI, and how you could bring, people talk about large language models, but how you could create your localized LLM or large language model and really be very context sensitive. That, okay, here is my, like, I mean, if you think about humans, right? Humans have, over the last, since they are born, every day they're adding some information to their own large language model. So in that sense, the ability that it provides, that, hey, you know what, I am a lawyer firm, and this data is very, very confidential. I'm a healthcare firm, this data is very, very confidential, it cannot leak out, but I still want the ability and accessibility by which I can tap into that information. And I can say, over these hundreds and thousands of PDFs where the information is stored, if I were to ask that question where it can give me some information, I think that ability is very powerful, because it's really, to me, it truly belongs to about unlocking the information. And if you're able to unlock the information and be more successful, I think that's mind blowing. And I think that's the capability that I'm excited about. AI, generative AI brings to the realm. Now, a lot of people are like, oh, we should pause the AI experiment. Let's not be afraid of it. I mean, it's a new tool, ready or not, it's going to take over our lives. So let's use it as an effective tool and, like, move on to the next journey.
Absolutely. I have a couple of questions on Gen AI, so I'm going to come back to you on that. But Arun, both of us have seen the evolution of Kubernetes, in the last 6 7 years. So currently, the Kubernetes world is split into two. One is the conformant API based distributions, uh, like RK2 and upstream Kubernetes, then Tanzu, OpenShift, and so on. That has that has settled down and established, and customers have some kind of a checklist and guidance to go buy a specific distribution, a commercial one, or use open source. But on the public cloud side, and interestingly, you have been a part of this at AWS when ECS was launched and Fargate was launched. So there is a lot of fragmentation of these proprietary services like the App Runner on AWS or ECS, Fargate, Azure Container Apps, Google Cloud Run. And all of them are based on containers, but they don't adhere to Kubernetes. They are not exposing the Kubernetes API, and that is actually a little bit concerning to the developer sitting outside, because the world is getting split into two: API conformant Kubernetes distributions, and then this proprietary black box, opaque managed services that are highly fragmented. What's your view on this?
Yeah, no, I think I don't see the world that it is split into two. End of the day, to me, it really boils down to, what does the customer need? Kubernetes has a steep learning curve. So you may think that, oh, because I'm staying open source, because I'm staying conformant, because I'm using, an API that is driven through a community process, I'm going to be happy. Not at all. Kubernetes has a steep learning curve. As a developer, if you are a Java developer, if you have been building, say, Java application, now you need to understand, what is the CNI plugin I'm going to use. That just blows your mind sometimes. Now you need to understand, what is the CSI plugin I'm going to use to make my application most effective. All of a sudden, an application developer has to start understanding the deep networking fundamental. You need to start thinking about, how I'm going to create these Helm charts, how I'm going to create, you know, how I'm going to scale this application, I need to understand those elements. And that makes it very confusing, actually. And I think that's where these, I wouldn't call them proprietary closed source services, really work very well. Because oftentimes, at least when I was at Amazon, customers would come to us, they would say, I'm hearing everything around Kubernetes. It's exciting, but here is my problem. And so we would always approach the customer with what is their problem, as opposed to here is the solution. Let's figure out how do we wrap your problem in this. So I think the key element here is what is the problem customer has, and if customer doesn't need all that, API maintenance, they don't need portability. They're totally belonging to AWS or Microsoft or Google, whatever cloud they're using. I think it's perfectly fine to use their services, because end of the day, it's about what is the value that you're providing to customer, at what cost are you providing, what is the convenience are you providing. And the thing that I've seen, for example, ECS was actually launched far before Kubernetes was a thing. So in that sense, ECS has always existed, right? I mean, I'm more familiar on the Amazon side. So ECS has always existed. And in that sense, as customers were coming to Amazon, ECS was a really easy start for them. Kubernetes, after now 6, 7, 8 years, is a bit more stable. There are still challenges, but the steep learning curve and all those things. But you know, customers when come to Amazon, it's very clear, what are you trying to solve. Do you need deeper, super elaborate integration with the AWS services, or do you really care about open source? They may say that, hey, I'm coming in, our corporate strategy is AWS, but we also want to be open source compliant, in which case then Kubernetes is a natural choice. But then they may say, hey, our corporate strategy is AWS. We don't care about which service we pick, but what really matters to is quick way to get the application up and running, and in how many zones, how many regions the service is going to be available, how much it can scale, which customers are running, what skill set do I have internally, what can I hire, where can professional services be available. So I think it's never as they say, Nora, right? No one right answer. So in that sense, it's always a nuanced conversation with each and every customer, and I think that's the most beautiful part of it.
Perfect, perfect. Completely agree with you. Now, extending on that, again, something related to the cloud native ecosystem, there is a lot of excitement around WASM. So again, as someone who has seen this evolution transformation, what's your view on WASM? For me, it is like there is AMD 64, ARM 64, and there is WASM. But how do you look at that?
Yeah, no, I think WASM is definitely over the last year or so has gained a lot of traction, and it does provide a portable mechanism where you can create that entire stack and you can run it whether on the edge, whether in it on the VM, it doesn't matter. So I think the excitement is definitely building up. CNCF is actually planning a WASM Con. So there's a first WASM conference happening essentially, but I think it's still in early days, on what it needs to be and where it will prove itself successful. There are a lot of language bindings. If you're writing your application in Go, for example, and then you can say, you know what, okay, create my now WASM assembly out of this so that you can just deploy this anywhere. So I would say it's still in early days. I'm not saying it needs to prove, but how does it run at scale? Day one is always easy with any technology. What does the day two look like? What happens when the application breaks? What happens? What are my debugging capabilities into it? How do I trace my application? How does it mix up with my existing containerized applications? How does it mix with my existing workloads? How does it integrate with my existing services? So I think a lot of that is still to evolve, but definitely an exciting space and must watch for me.
Absolutely. Every time I play with WASM, it gives me sort of deja vu. It's almost like going back to the early days of LXC, trying to figure out how do I talk to a stateful service, how do I interoperate, all of that. So absolutely. So Arun, you are a part of the Open SSF, the Secure Software Foundation governing board, right? So with AI becoming almost pervasive and influencing and impacting almost every domain of the software development lifecycle, How do you see AI impacting the software supply chain, and particularly from the context of OpenSSF?
Absolutely. Well, I have been part of the OpenSSF governing board for now about a year. OpenSSF, for those who don't know, is Open Source Security Foundation. Last year, they defined 10 mobilization streams, in what they're going to work on, and those streams are like, hey, everybody should have a SBOM. How could we fix? How could we promote? How can we do more education around secure guiding principles? How do we fix the tools? How do we improve the CI/CD process? So they're truly trying to improve the posture of open source security, essentially. But now with AI, as I was saying, is influencing each and every part of our life. I think that's the essential element here. So it changes the game a little bit. In the near term, I think developers that utilize, say, generative AI solutions will probably create code that will be less secure than those that are using without generative AI. Let me tell you why. Because there's a research that was done that shows Copilot, actually, which is GitHub Copilot, it can generate more vulnerable code, up to 40% of vulnerable code. And the reason for that is because Copilot is trained on the vast amount of data that is available or code that is available on GitHub. You don't know if that code is so secure or non-secure. So if it is going to be trained on all sorts of non-secure, potentially malicious, potentially vulnerable code, it's going to give you those recommendations. It doesn't tell you that this code is secure. So the warning in that paper was that, hey, developers should remain vigilant when using Copilot as copilots. That's essentially the point. Now I know GitHub is aware of the issues. They're working on their new feature has something like vulnerability filtering scheme, so that you can block insecure coding patterns such as SQL injection or so. But that's end of the day, that's one element of it. Now, if you think about static analysis testing, that's again a key part of your secure supply chain tool chain. One of the challenges over there, it really builds upon pattern matching, right? So there are a lot of false positives that happen in secure static analysis testing. But that's where AI could be leveraged to hopefully alleviate some of those false positives, so you could actually leverage it more effectively. Another way it could impact software supply chain is submission of bad code to the repository. Currently this is basically mitigated by human code reviews. Highly possible that AI could be trained to find these items early on, and this is injected right as part of your CI/CD pipeline. On the other side, attackers could use LLM to create more vulnerable code for submission to open source projects. Think about a DDoS attack on a project where, let's say, the language I don't know, I'm going to use generative AI to create a code, and I submit a bunch of pull requests to the project. Now the burden is on the maintainer to go through those lists and say, I don't know which pull request to submit. So everybody, like OpenSSF, LF, CNCF, every foundation is really going about, should we accept the code that is generated using generative AI? Now, one of the areas that generative AI has been of masterful use by malicious actors in the area of phishing email. So, very concerned that malicious actors are going to take that kind of capability and take it into a new direction, which may cause some havoc for the security community. Well, I think LLMs could be very useful to malicious actors for typo squatting attacks. But on the other hand, you could actually train your model so that you can avoid the URL hijacking, because you can start realizing humans' eyes sometimes cannot catch the slight change in the URL, but the models, that's where they're good at. They could start leveraging it. And I guess the last part that I want to say about it is from the product's perspective. CrowdStrike, for example, already uses AI to look for malware. There is Intel threat detection software, for example. It also uses AI ML to analyze systems running on to detect ransomware. And I'm expecting that over the years, this will only grow more and more and more, where AI will be used both by the malicious actors and by the good people, and that struggle will always be there. The good, healthy tussle will always be there. It's anybody's guess who's going to win.
Absolutely. So when you mentioned about Copilot generating vulnerable code, it reminds me of ChatGPT hallucinating, right? So, what hallucination is to normal end user, generation of vulnerable code is to developers. So we got to be very vigilant in how we consume this AI generated content. So, uh, one final question, Arun, before we wrap up this show. So, Intel plays a significant role in edge computing. They have ASICs, they have FPGA, they have accelerators that run in very small form factors. And I use Intel's Mirai X VPU extensively in accelerating, vision inference. Now, one of the things that becomes more complex is the growth of generative AI and foundation models. So, if you look at foundation models and generative AI, right, it is very cloud centric, and they are running on clusters of GPUs, and they require a lot of horsepower. So, where do you see Gen AI and Edge meeting? Are they going to be two different silos, or are we going to see convergence? What is your viewpoint on this?
Yeah, no, I don't think silo is the right word. I think edge or cloud native, whatever it is going to start leveraging Gen AI to be a lot more effective manner. I think that's sort of the way I see about it. I mean, if you think in terms of say cloud native, for example, right? How this would help cloud native. The other day, I was looking at a YouTube video, and I saw a tool called as Kate's GPT. Now, this is a tool for scanning Kubernetes clusters, diagnosing and triaging issues in simple English. You don't need to remember your deep Kubernetes commands. You can just say in English, and it'll help you triage. It'll translate that English using NLP into your Kubernetes commands, and it'll start giving you that data. So I'm really excited about the ability to bridge generative AI and cloud native together, essentially. Lots of different ways. If you think in terms of predictive capacity planning, there is a complex relationship between workload characteristics and existing resource use patterns. So you can use that to predict future resource and use it more accurately. Automated infrastructure provisioning could be derived from that, where I could say, um, help me understand what are my predictive use patterns, and then based upon that, provision my infrastructure automatically. And that's my language model that is already done. Anomaly detection is another one. It's much of an art than as a science. So that's where you can train your models on normal patterns or behaviors within a cloud native environment. These models can then be used to detect anomalies or deviations from the expected behavior. So that's another element that I'm excited about. Performance optimization, synthetic data generation for test and validation of your models, or rather your workloads, and then auto generating code and configurations. I think you could start leveraging this in a whole different direction. And that's my point. As I said in the beginning, AI is here to stay. It's not going anywhere. Generative AI is here to stay. Let's embrace it. Let's figure out there is resistance is futile, as they said, right? So it's important that you understand how this is a very powerful tool that you can leverage for your benefit, your advantage, and make it work for you.
Absolutely. I did deploy Kate as GPT, and it looks very promising. That is I think that is where the cloud native world meets the Gen AI world. Um, I've also seen agents that can generate kubectl commands for errors that your control plane generates. So it's a fascinating intersection of cloud native with LLMs.
Yeah, I mean,
Awesome.
let me give you an example. For example, Jim Zemlin talked about it in the LF board meeting, and he said that earlier it would take them 6 to 9 months to create a Kubernetes certified developer exam. Now it takes them a week. I mean, this is massive, right? There is still a human element involved because generative AI is still a bit stupid because that's where the human element comes in. So you got to make sure it tweaks it. It looks consistent, but leverage it as a tool to be more effective.
Right. Right. Absolutely. Wonderful. So, Arun, thanks so much for joining my show. It's been wonderful talking to you and getting your insights. As I mentioned, you have seen the evolution and multiple waves of technologies. So, tapping into your experience and getting these insights are valuable. So thanks again. We'll do a follow up when we have more to talk about LLM's intersection with cloud native.
Absolutely. Thank you, Jankiram, for having me here.